So for this, okay, for this related to only I'm telling you what they want. Okay, related to that only I'm going to discuss now. My first thing is what you know already. I will discuss. Okay, these things are very important. They will ask some of the basics also, according to me. Okay, so first important thing is first basic is PTSP. You know very well. Okay, probability theory and stochastic process. This is very important. Without this, you cannot understand communication subject. You know very well. In PCM to calculate quantization noise, in digital modulation techniques to find probability of error of ASK, FSK, PSK. For all those things, this is very important to find noise, to do the noise analysis. Okay, noise we generally assume eddy to white Gaussian noise. For that also PTSP is required. Okay, so what is probability density function, distribution function, all these things once recollect, surely they will ask. Okay, and one more thing is once see 2 or 3 videos are there in YouTube channel. They are doing in Qualcomm. They explain very clearly how they will ask all these things. Okay, you can same thing. Mostly I am going to explain, and along with that I will try to explain the concepts also. Okay, clear. So next one is one of another first related to communications I will write. After that signal processing related I will write, and next one is this is related to communications. Okay, clearly communications point of view only I'm going to discuss, and analog and digital communications. I think you have subject ADC, analog and digital communications. This is another important subject. Okay, and third one, information theory and coding. I think some of the students attended ITC classes. Okay, remaining students, they have ITC subject, information theory and coding, in this only last unit. I think if you remember, in analog and digital communications, last unit is information theory and coding only. Okay, clear. So otherwise information theory and coding, this is also very important. Information theory, how you plan, that is different thing. Okay, information theory and coding, try to plan according to this one. Again I'm repeating, I'm discussing, not just like that what you know, what they will ask mostly. I'm discussing in that point of view only. Okay, clear. And next, last one day before, I have seen long time before only those videos, all these things I have seen different people. Okay, anyway, and one more thing is along with this. Okay, first of all we'll see this is related to communications. Okay, and also related to signal processing, signals and systems and signal processing. In that, important thing is basic subject is SS, signals and systems. Okay, next one is digital signal processing. This you know very well. So which topic you have to concentrate, that also I will explain. Not all the topics. Anyway, you refer all the topics, but mostly what they concentrate, most of the people they are interviewing. Okay, mostly they will ask some questions, repeated questions. I will tell you those questions. Okay, in all the subjects, not only this one, all the subjects. Along with this, up to this part. Okay, this is only 50%. Okay, because you maybe they will take as a modem system engineer, very experienced people in general. They need MTech in communication systems, PhD from IITs or some of the standard universities. They used to take like that. First time it is coming to our college. Okay, Qualcomm. So concentrate more. Excellent company. Okay, if anyone selected means that is good only. Okay, along with this, mostly they will ask these questions only 30% only. I'm talking about MTech communication systems. Mostly they will take those people only. Okay, I'm talking about modem system engineer job for those only. They were entering as a BTech fresher. Okay, their expectations mostly it may be increased to 50 to 60% or maybe 80%. Okay, clear. Basics. So mostly they concentrate on LTE. Why LTE? Okay, what is LTE? Long-term evaluation. This we are using in 4G. Okay, for 4th generation communications. In that, some of the concepts are very important. Okay, you have to know Lte Stack Protocol. Note this point. I think some of the students don't know anything about what is Stack Protocol also. I'm assuming like that. Okay, Stack Protocol. LTE Stack Protocol. This is very, very important. Mostly, surely they will ask, I can say. Okay. So Lte Stack Protocol. So I'm not going to explain each and everything very clearly. I will show you how it will be. So what you have to study. All these things I will discuss in my particular time. Okay. So this is very important here. Try to understand Lte Stack Protocol and also Lte architecture. This is also important. What is Lte architecture? I will show you something in particular textbook. Okay, I downloaded long back, not now. Long back standard textbooks related to these. I show you those textbooks also. If you want, you can download it from some of the website. I will tell you. Okay, I can download it. Is it clear, Nana? So these are very important. They will ask you. Along with this, if you can answer this question, they will surely select you. If you know up to this point, if you refer only these topics, if you tell you anyway, anyone can tell you. Not anyone who prepared nicely, they can tell you. But along with that, if you try to spend 2 to 3 days on these topics from fourth one onwards, along with this, surely they identify you. Okay, you know very well. At least not everything, something you have to talk about this, because Lte Stack Protocol means no one can tell you. Lot of things are there. At least some things you have to know. Okay, I will tell you what are the lot of things, all these things. Okay, clear now? And next one is what we are using in Lte, long-term evaluation. Okay, we are using FDMA or something or TDMA or any other technology in Lte, particularly Lte. We are using Ofdm. Okay, you know Ofdm in our lab also, but I will try to explain somewhat. Okay, in Qualcomm point of view, what they will ask mostly. Okay, I'm telling again mostly, but they may ask anything. Okay, Ofdm, orthogonal frequency division multiplexing. Okay, this is also very, very, very important. They are very interested about this topic. Comparatively, all other topics, they are very interested in this topic. Remember this point. If you want to, if you are giving answers, means they will continuously in your time they will ask about Ofdm only. Okay, that much interest. Okay, clear? So try to prepare this one along with all these things. Within short time, try to refer all these topics and try to refer Ofdm. Okay, now is it clear? So Ofdm is very important. Along with this, last one is MIMO. This also they will ask. Okay, what is MIMO? Multi-input, multi-output. This is also very important. Okay, so if you have these things along with this, as they will take surely. Communication point of view, I am discussing. They are asking about Python. If you see the profile, try to open that and try to observe. Mostly they are asking Lte protocols only. In that also, they mentioned clearly 5G. Okay, no, if you know clearly about 4G, you can answer anything related to 5G. Okay, clear? If you want to, sir, where I have to refer? So if you open YouTube or NPTEL, you know very well about NPTEL. In that CDMA, Ofdm and MIMO. Okay, related to this one, some subject is there. Okay, so CDMA, Ofdm and MIMO, Aditya Jagannathan sir. Okay, Aditya Jagannathan sir. Okay, so if you can refer this one, you can cover these two. Okay, you can cover. This is more than enough. As a BTech student, it is around 20 hours, 40, I think around 40 to 48 videos, 20 hours around. Okay, if you can spend these 3 days around 20 hours, yes, 100%. If they ask you communications, try to, don't leave, all of you, don't leave this one. Okay, again I'm repeating, don't leave this one. Aditya Jagannathan sir, CDMA, Ofdm and MIMO related subject is there. Okay, don't leave that one. And I think you don't have in BTech level estimation theory. They are very interested in estimation theory also. Okay, estimation, you know, maximum likelihood, ML. Okay, if anyone prepared about GATE, they know ML. Okay, maximum likelihood, and also minimum mean square error, MMSE. Anyone knows? Please give an answer. MMSE. Anyone knows about this MMSE estimation? Okay, if you know, prepare. Otherwise, I think they will not ask. They have not mentioned anything what you have to prepare. Mostly they will ask estimation theory also. In that they will ask ML and MMSE, minimum mean square error. I think this is about what they will ask mostly. Is it clear? Again, I'm repeating, don't leave this topic. Okay. Try to start today only if you are interested to work in communication related to communication, because they mentioned clearly LTE protocols, all these things. Try to prepare this one. Is it okay? Clear? So don't leave this topic. You can cover these two. For this, we have to prepare in our own only. I will tell you some of the textbooks. Try to refer. Okay. Clear? Anyway, first I will cover basic subjects, all these basic subjects, what you have to prepare. We have 1.5 hours more. Last half an hour we will see. I will explain what is Yftm and what is MIMO, what is the advantage of Yftm. Some of the topics you can answer. Okay, I will explain. So total 13 in our class. Okay, no problem. Okay. Is it clear, Nana? Anyone please respond. Is it clear?
Yes, sir.
Yes, sir.
Okay. Someone raised your hand. Why? May I know?
Sorry, sir.
Okay, no problem. No problem. These 13 members very much interested. Again and again I am telling, try to start after this class immediately. Okay. Need not to spend other time also. I can say confidently. Okay. Start preparation of IEEE Jagannathan sir classes related to Ofdm and MIMO. Okay. So if you can answer, sorry, I know about Ofdm means Qualcomm people will feel like anything. Okay. They are very happy. Okay. Clear? So start preparation that a lot of mathematical analysis is there, that much not required. Try to understand what is there in that, what is Ofdm, what is MIMO. So that is also related to probability only. Okay, some of the probability concept means expected value. Okay, how we can expect. Anyway, I will discuss clearly. I will try to go open that also. I have that notes also. I'll choose answer notes. Notes in the sense are notes only. You can download it from website. How all these things I will tell you. These 13 members, if we can answer this one, surely they will focus on you only. Okay. Anyway, in lag and display communication, anyone can answer. Okay. I think you can understand. But basics also very important. So first of all, half of the time we will see basics. Half of the time I will try to explain. Okay. Ofdm, all these things. Anyway, concentrate. And if you want to discuss, you can discuss with me. This is just like that. Okay, there is not our regular class. You can discuss with me. It will be like a discussion. Okay. So first of all, what are the things you have to cover in probability? I will try to tell you. PTSP. Try to spend some time on PTSP. Without this, you can understand Ofdm and MIMO. Okay, clear? Expected value, something. Okay, we will calculate bit error rate. Okay. I think you know what is bit error rate. That is nothing but probability of error. We discussed like this. I think for some of the students I taught this analog and digital communications, they know probability of error. Remaining students also knows. Just I'm telling. Bit error rate. This is very important. What is the advantage means you can compare always with the bit error rate. You can tell you what is the advantage of MIMO, sir. We can reduce bit error rate. Okay. So how we can reduce? I will tell you. I will tell you in this class what is the great idea behind MIMO. Why they started Yftm. I will explain some part, some concept. Okay, I will explain. Okay. Anyway, so in PTSP, you know all basics. What is set theory? I'm not going to explain. What is Bayes theorem? Okay. So once try to know about Bayes theorem. Don't neglect this one. Bayes theorem and total probability theorem. Total probability theorem. Try to note down them. Try to note down some of the things. Okay. So this is the starting important point. Okay. Bayes theorem and total probability theorem. Very, very important. Yes or no? Conditional probability you can see. Okay. What Bayes theorem means? Just 1 or 2 minutes I will explain. If it is the sample space, I'm dividing sample space into 4 parts. Simply I'm telling. Okay. So this is for example B1 and B2 and B3 and B4. Okay, B1, B2, B3, B4 all are independent. Okay, independent and mutually exclusive. Okay, not independent, that is different thing. Just mutually exclusive. In that, I am defining one more event, that is A. Okay. So what is total probability theorem says? What is P of A? What is the total probability of A? How we can define this one? Okay, this is P of A. What is P of B1 by A? Okay, that is Bayes theorem. Okay, some condition we will apply. How we can find that also? We can get from the Bayes theorem. Simple one. So how we can find this part? Okay, and also how we can get this part? That is nothing but total probability theorem and conditional probability. Don't think in different way mathematically. Simple thing is, what is this part or individually this part or this part? Okay, how we can find from all these things, how we can find this part, and how we can find this part from all these things? That is nothing but Bayes theorem and total probability theorem, nothing else. Is it clear? So once refer this one also. Like this one I will explain. I cannot explain each and everything clearly. You will not get what are the things required. I will try to explain. Okay, that is good. I think if you have any idea, let me know. And next one is, okay, and distribution function and density function. In that conditional distribution, you will get a lot of distribution and density functions throughout probability theory. So distribution and density functions okay, and density functions. This is very important. Distribution and density functions are very important. Without I need not to say very important. Without this, I cannot analyze anything also. Okay, so what is distribution function? Fx of x equal to probability of x less than or equal to x. Okay, before going to start this one, I want to tell you, you have to know the clear difference between random variable and random process. Is it clear? You have to know the difference between random variable and random process. Try to recollect it. I will tell you within 1 or 2 minutes. Try to understand. Okay. The advantage of random variable is, okay, for example, any outcome of an experiment, you can give some real value. That is nothing but random variable. Again, I'm repeating. Any outcome, take any outcome of any experiment. For that, you can assign some real value. What it means? Okay, consider tossing a coin experiment. Okay, sample space will be head, comma, tail. Is it clear? Sample space will be head, comma, tail. In this, any real value is there? No. So how we can do mathematical analysis? To do mathematical analysis, I have to assign some real values. Maybe I will assign for this one is 0, and I will assign for this one is 1. This is nothing but random variable. So how we can define now? X equal to x1, comma, x2. What is x1? Equal to 0, x2 equal to 1. What is the outcome for this experiment? Tossing a coin is an experiment. Outcome is head, comma, tail. Now I assigned 0 for head, tail. I assigned 1. Now I can represent mathematically some graph or something. How can represent 0 and 1? If you want to give the probability values, you can give probability values. That I will discuss in distribution and density function. Okay, how it is distributed, what is the probability. So first of all, what is random variable? For any experiment, we have to assign some real value. That is nothing but random variable. And one more thing, rolling a die experiment. Consider rolling a die experiment. What are the possible outcomes? 1, 2, 3, 4, 5, 6. Yes or no? So you may get it out. Sir, all these things are real values only. Okay. Rolling a die means you will get outcome like this. Okay. Is it clear? So I'm considering this is 1. Sometimes top of the face you may get a 2. Sometimes top of the case you may get a 3, like this. If I assign real value, I can assign real values like this only. Otherwise, this is sample space. Otherwise, I can assign real values like 2, 4, 6, 8, 10, 12. Like this also I can assign 2 times this value. I can assign. Okay, clear? Not a problem. How we are assigning real value? With some condition. Yes, by considering some condition you can assign, or generally also I assigned here. Okay, is it clear? If it is 2 means assigned value 2 for getting 1 on top of the face. You got 2 means I assigned 4 as a random variable, like that also. Is it clear? So assigning some real value is important for any particular outcome. Clear? And one more thing is, whether it may be continuous or discrete also, random variable, try to understand that also. What is continuous, what is discrete random variable. For example, spin a wheel. consider that one. Spin a wheel starting from 0 and up to 12. Okay, in that, if you spin this wheel, you may get a value in between 0, 3, 6, okay, 9. How many values it has? Infinite values. You may get infinite values. It may be 2.2.2, some 2.222, something or something. We cannot define. You may get infinite values. Is it okay? If I get in between 0 and 3, if this wheel, this pointer in between 0 and 3, I can assign 1. I can assign only 1, 2, 3, 4 values. This is discrete assignment. What is the meaning of 1? If this pointer is in between 0, 3, okay, clear? So, and one more thing, they don't want mathematically all these things. They observe you the concept. Okay, this is the best time to prove your knowledge. Try to understand. Okay, clear? 0 to 3 means I assigned 1. I assigned real values. This is a discrete assignment. Can I assign continuously? Yes, you can assign 0, 3 also. 0 less than or equal to x less than or equal to 3 or less than or equal to 12. This is also I can assign like this. This is a continuous assignment. How can I assign continuous random variable? Is it okay? Like that also I can assign. Try to understand. So it is discrete and continuous. Anyway, I will not spend more time. Try to clearly know about random variable and random process. And what is random process? Mostly I will tell you this example only. Okay. So I think I have in this class, I think 13 to 14 students are there. For example, if I have given resistor to all the students, this is the most common example from I have taken from IIT professor only, Gautam Das. Okay, law communications by Gautam Das. Anyway, so for example, this is a resistor. If I have given same resistors to these 13 students, I asked you to observe current. Okay, ammeter. I have given ammeter. I ask you to observe the current reading. Is it okay? Clear? Will you get the same outcome? I have not given any power supply. So without power supply also you will get some current. Because of random movement at room temperature of electrons, you will get current. First value may be like this. Second waveform is also like that. With respect to time, current is changing because random movement. Because of this, you will get random waveform. Second person will not get same output. Maybe same resistor, same ammeter, but temperature variations, lot of factors. Because of that, some other person may get output like this. Some other person may get output like this. Some other person may get output like this. Is it okay? And if you observe all these things, all these called as sample functions. Is it okay? Sample functions. This is also sample function. This is also sample function. This is also sample functions. Okay. All these sample functions are called as a random process. I considered T. Observe this one. Previously, I have not considered time. Just I assigned some real value. So random variable, we will not consider time. But in random process, we will consider time. Morning 10 o'clock, you came to lab. I have given resistors and measure outcome 10 to 10:05. 5 minutes. You observed output 5 minutes. You may get the graph like this. Some other person may get. I think you understood. So I included time. I have specifically given time. That is nothing but random process. All sample functions include random process. From this, can we get random variable? Yes, we can get random variable. Specify. All of you take the reading at 10:02 AM. Yes, all have taken reading at that instant of time. Is it okay? Clear? This is time instant. This is the value. As a BTech student, they may ask clearly about all these things. Okay. Try to concentrate now. I will complete it within 1 minute. Okay. This is this one. Is it clear? So these are all different values. So now measure, take all these values. It may have -1, maybe +2. I'm not giving whether it may milliamperes, nanoamperes, microamperes, not required. Just try to understand, but different values. Try to note down all these values. Okay. For example, 4 functions, consider 4 values. Okay. Clear. So now it is nothing but random variable. Okay. Some particular time. Okay. Because of that, generally how we represent x of t comma s. S is the sample space. This is the total sample space. In that specifically I mentioned time. So this is nothing but random process. Is it clear now? Okay. Mention time, that is nothing but random process. Anyway, what is density function? Okay. Distribution function I mentioned already. Simple example, I will take head comma tie. Okay, and if it is not required, let me know. Okay, not a problem. I will go to some other topic, but try to understand. I divided into some parts. I planned this class in different parts. I will try to cover all those parts. Okay, 5 to 10 minutes I will cover each and every subject. What are the things you have to refer? Okay, try to concentrate. So I assigned, for example, -1 1. Previously I assigned 0 1, not a problem. I assigned -1 1. So -1 and 1. Okay, so what are the probabilities? Head comma tail probability, you know, 1 by 2. Mostly we will take 1 by 2, 1 by 2. Okay, first -1. What is that value? 1 by 2. This value is 1 by 2. Sorry, this is 0 point. Okay, and it will be again 1 by 2. So 1 by 2 plus 1 by 2. What is this value? 1. Okay, this value is 1 by 2 and this one is 1 by 2. What is this one? Fx of x, distribution function. How it is distributed? Final value should be 1. Okay, in every cases, distribution function final value, because if we add all the probabilities, finally we will get 1. Is it okay? What is the density function? We represent generally fx of x, small fx of x. Okay, that is d by dx of, don't confuse Aditya Jagannath sir will use for density function capital F. That is not the important thing. Try to understand whether it is distribution function or density function. Most of the textbooks follows like this only, what I am following. But if you follow Aditya Jagannath sir classes, R represents capital F. What is that? For this capital F. Okay, don't confuse. That is density function. Okay, just I am giving information. I told you follow sir classes. Okay. Anyway, I'll leave about that. So d by dx of fx of x. Okay. Rate of change of distribution function. Now if you draw the distribution function for this experiment only at -1 and at 1. At -1, what is the rate of change? How much it is changing? Up to this point there is no rate of change, yes or no? But here what is the rate of change? 1 by 2. So you will get 1 by 2. Okay, you will get 1 by 2 value here. More clearly also I can explain, not required now. And from this point to this point, what is the rate of change? 0. From this point to this point, how much rate of change? 1 to 1 by 2 to 1, again 1 by 2. So you will get impulse response. This is the fx of x. You may get it out. Sir, density function always continuous. No, density function will be maybe sometimes discrete also based on the density function. Distribution function. Is it clear? So this is about discrete. How continuous density functions. Try to concentrate more on density functions. In communications, mostly we will use density functions. Okay. Both are equal importance only. Just I'm telling fx of x. So try to concentrate. Okay. Gaussian density function. Don't neglect this one. Gaussian density function. Okay. I think you have within 1 week. I think Qualcomm. Try to concentrate. If you have any other work also, you can do along with this. But try to concentrate more. What I am talking with you. Try to do. Surely they will impress them. Surely, if you talk about all these things. Okay, Gaussian density function. This is about Gaussian density function. Am I clear? So this is Gaussian. Okay, 0. This is mean value 0. Okay, what is the Gaussian density function? Fx of x. If you remember, try to remember this 1 by root over 2 pi sigma square e power minus of x minus mu whole square by 2 sigma square. Am I correct? This is the Gaussian density function. In that mu is the mean value. In this case, I consider mean value 0. For example, it has some mean value. This is 0. And Gaussian density function may have some mean value. So it has maybe 1. So now mu equal to 1. In this case, mu equal to 0. What is variance? This is the variance. This distance is nothing but variance. Okay, sigma square. This is sigma square, variance. Maybe variance is low. It may be like this. Variance is high. It may be like this. Variance is very high. It may be like this. Is it okay? I can say clearly. Variance is less. Variance is high. Variance is very high. Okay. So why it is like this? If we integrate any density function over the interval minus infinity to infinity, fx of x dx equal to 1. Why? If we add all the probabilities of an experiment, will you get 1 or not? Yes, you will get 1. Similarly, if you know the outcome, for example, in tossing a coin experiment, head, comma, tail, each probability 1 by 2, 1 by 2. What is the value? 1 by 2 plus 1 by 2, 1. I know the outcomes, countable outcomes. If it is uncountable, consider noise. Okay, draw the noise density function. Okay, consider noise. Okay, for example, try to understand like this. This is the noise function. Are you able to follow? Anyone? Please respond.
Yes, sir.
Okay. Consider noise. Noise is nothing but unwanted signal. This is, sorry, this is some noise. Okay. So noise voltage is in between. Okay. -4. This is not -4. I will not give high value. -1 and +1. Okay. Noise in between -1 plus 1 volt. How many values in between -1 plus 1 volt? If you see at any instant of time, some value is defined. So infinite values. So this noise function is defined in between -1 and +1. -1 and +1. Okay, which is less probable and which is more probable? So high voltage terms are less probable. Am I correct? See, but low voltage, most of the time signal is around low voltage. Is it okay, clear? So low voltage amplitudes are more probable. Try to understand. This is more probable. If I draw the function like this, am I correct? Yes, it is correct only. So mostly we will take Gaussian. Why Gaussian means? This is the reason. Most of the times, if you take practical any signal, if you consider speech signal, my speech signal. So if I am talking with you, if you convert into electrical signal, if you observe signal will be like this. Sometimes, okay, the amplitude is very high. Why sometimes amplitude is very high? Some of the words, some of the letters, we have to pronounce with some high amplitude. Okay, high pressure. Okay, what is that word? F. Think about F. Okay, we have to apply more pressure for those words, and also if you shout loudly in those cases, output will be very high. Otherwise, mostly my voice is around 0, like this only. For that also, I have to represent Gaussian. Is it clear, Nana? So most of the times, low voltage terms are more probable, high voltage terms are less probable. But we have to represent continuous only because it has infinite values. I cannot add all infinite values. But how can represent mathematically? Integral. Minus infinity to infinity. Signal may be defined in between -1 plus, but in general, minus infinity to infinity fx of x dx. What it is giving? It is giving probability values, but it has infinite values because of the continuous. Okay, if we add two probabilities, 1 by 2 plus 1 by 2 will get 1. If you add infinite values, this should be always 1 only. Okay, what it means? If we integrate this signal in between minus infinity to infinity, okay, dx, you will get 1. That is the Gaussian. Any density function, if you integrate, you should get 1 because it has some probability values. Sometimes some less probability values. At some particular value, you may get more probability value, but final it should be 1 if you add. Integration is nothing but cumulative addition. That is also addition only, but cumulative addition, if you add all these things, you will get 1. Why is it clear? These two things are very important. Anyway, I will not spend much more time. What are the different density functions? Gaussian, binomial, uniform, Poisson, exponential. Okay, Rayleigh also very important. Nana. Remember this point. Why? Okay. In MIMO, I will tell you. MIMO, if you see, excellent concept that is in that Rayleigh density function you will get. I will tell you where you will get. Okay. And not only that, you have to know about conditional distribution and density functions. Remember all these points. And operations on distribution and density function, what it means, expected value. Shall I discuss? We will leave now, already 10:50, 11 o'clock. Okay. I will tell you. Movements also you can see. Okay. First order movement, second order movement, what is variance? Okay. What is standard deviation? What is skew and skewness? Don't leave anything. Just refer within some time. Fix some time. These 5 days, 10 days, plan it properly. Because okay, excellent company. I cannot explain more than this. Okay, if you got, you'll be so happy. Okay, anyway, and random process density function fx of x. Okay, in a random variable concept, but in random process concept, fx of x comma t, we represent t also like this. Time also you have to include it. Probability of x of t1 at a particular time instant less than or equal to x1. Okay, I can explain more clearly, but Okay, time not sufficient. Try to understand this also, how we can represent. And one more important thing is very important. They ask you autocorrelation. See those interviews, those people interviews immediately after this class. Modem system engineer or communication engineer, search in YouTube. 3% interviews are there. Try to note down what they told. Try to prepare. Okay. Anyway, there is a chance of asking as a EC student. Okay. Maybe not exactly modem system engineer. That is not our role. I have seen software engineer related only. But you have to implement protocols, all these things. Okay. But because of that, you have to know. Anyway, autocorrelation. Autocorrelation. What is autocorrelation? What is cross correlation? Okay. This is also very important. And first order stationary. What is stationary? Try to, if you have any doubts, you can call me now after class also. In these 4 to 5 days, if you have any doubt, you can call me and you can discuss with me. You can ask me the plan also. I will tell you because I have seen very closely. I can say that only up to that point only. Okay. So cross correlation and covariance also. Covariance also. Okay. And cross covariance. Autocorrelation, cross correlation, covariance, cross covariance. Very easy. Okay. Cross covariance. Try to refer Pebble's textbook, otherwise Mallikarjun Reddy. Okay. And finally, with 1 minute, I will stop this subject. Power spectral density. Okay. This is also very important. Power spectral density. What is power spectral density? Name itself, spectrum and power relation. Yes or no? Spectrum means x-axis frequency. Power means y-axis we will take power. Is it okay? If we take generally noise power spectral density, like this we will take. Why it is n by 2. If you remember, n naught by 2 or n by 2, something we will take. Okay. Why it is like this? What it means? Generally, noise is additive white Gaussian noise. Okay. I will tell you about this later. First we will see n naught by 2. Noise is having all the frequency components because you are transmitting a signal is having some particular bandwidth. This is the frequency. In a particular bandwidth, in this particular band, you are transmitting your signal. If you consider noise is not there in this particular band, you will not get any good result. But noise is there everywhere. We have to consider noise. Some other person is transmitting signal in this particular band. He has to consider noise is there in this band. If you consider noise is there in all the frequency bands, is it good or not? Because of that reason, we are considering noise power spectral density. Is it okay like this? N naught by 2. Okay, that is very important point. So frequency versus power relation, how we can get? You know the autocorrelation function Rxx of tau. What is the relation between power spectral density and autocorrelation function? So power spectral density we will get from Fourier transform of autocorrelation function. Am I correct? This is the relation. They may ask you what is the relation between autocorrelation and power spectral density. You have to tell. You know how to expand this one, integral minus infinity to infinity Rxx of tau into e power minus a omega tau d tau. Is it clear, Nana? So these topics concentrate more. Okay, you know already you have studied. Some of the students went to GATE classes also. Try to refer that notes also if you are good in that. If you are very familiar in that, need not to prepare different things. What you know, you prepare that. Is it clear? This is about PTSP subject. Next. Any doubts, ask me if you have. Okay. Now I will tell you analog and digital communication. What are the things you have to consider? I cannot explain concept now. I think you can understand. We have 1 hour only. Analog and digital. In which part you have to concentrate more? Surely digital only. Digital communication. But they will ask you analog also. Some basics as a BTech student. But if you have MTech degree or PhD degree, they will take PhD holders also for modem system engineer. Okay. As a BTech student, they may ask you analog communication. You know the difference between amplitude modulation and frequency modulation. In this, you have to concentrate for just what is the difference you have to see. Not required more than that. I think DSBFC, DSBSC, all these equations also not required. SSB and VSB. Try to see the power relations. Power relations. I think you know the power relations, sideband power and carrier power, how much we are wasting to transmit carrier and efficiency. Okay, clear? So try to calculate efficiency. These things try to concentrate. Enough. What is the difference? Here you have 2 sidebands and extra carrier. We remove extra carrier, not carrier. Remember this point. We suppress the carrier. If you remove carrier, you cannot transmit. Remember that point. Single sideband. In order to transmit two sidebands, consider one sideband. And what is the advantage of ST0 sideband? Okay. And one more thing, I have seen in one of the interview. So one person they asked about this also, FM. I will tell you which question. From that only I am telling. Not now, Nana. I have seen long back these interviews, all these things. Just I am giving information. Okay. What is FM? Sorry, angle modulation. I can say angle modulation. If it is a little bit speed also, let me know. So frequency modulation and phase modulation. Is it clear now? Frequency and phase modulation. So try to know the difference between what is the frequency modulation. Mostly you know about frequency modulation only, and try to understand the phase modulation. What they asked is how to convert FM signal into PM signal, how to convert PM signal into FM signal. They asked one question like this. One of the MTech students, they asked. Okay, clear? Try to understand this also. I cannot explain now. If you want, I will tell you in equation form. Okay, how we can write FM equation, how we can write PM equation, phase modulated equation. Okay, so write the equation S of t AC cos 2 pi f ct plus 2 pi kf integral m of t dt. Okay, AC cos of 2 pi f ct plus 2 pi kf integral m of t dt, and this one is AC cos 2 pi f ct plus kp into m of t. Okay, clear? These two are equation. If I have FM modulator, I have given message signal m of t, I will get FM signal. Am I correct? So see here, instead of that, if I give d by dt, derivative of message signal, if I have given, I will get PM signal. Why? This is integral m of t. If I give m of t here, I will get integral m of t. If I differentiate m of t signal, and if I have given that to the FM modulator, instead of m of t, I have taken d by dt m of t. D by dt, derivation integration will be cancelled, you will get m of t. Is it PM signal or not? Here instead of integral m of t, you will get m of t. So for FM modulator, if you differentiate message signal, if you give it to, you will get PM signal. Like that, similar way, if it is PM modulator, if I give m of t, I will get PM signal, phase modulated signal. Now integral m of t, if you give, instead of m of t, will get integral m of t, that is a phase modulated signal. Is it clear, Nana? So this asked, this also. So concentrate everything. They may ask anything. Okay. So this is about analog communication, narrowband FM, wideband FM. Okay, lot of concepts are there. You know very well. Try to refer those concepts. Okay, clear? Next, digital communications. So this is digital. So you know very well. First one is how to convert analog signal into digital signal. And one more thing, without sampling, I think. Do you know? Actually, if you are an experienced person, what Qualcomm people will do generally, HR person call you directly. First they will call you. If you apply offline, what is the process? I will tell you. Okay, just for understanding. Mostly HR person call you. Initial, that is the first round of interview. Second round, third round. Actually 3 rounds. First round, what is third round? First round, HR person will call you if you apply offline. I'm not talking about online. That is different process. Okay. Generally, what they will ask you is sampling. Okay. Because whether you know or not, you are eligible to interview next 2 rounds or not. Just initially they will ask what is sampling. Very, very basic questions they will ask you. If you can answer this one, then they will conduct interview for you. In second and third round, they will mostly ask about Ofdm, MIMO. For a MTech professional student, I'm telling you, for modem system engineer. Okay. Because as a communication faculty, I can discuss that part only. I cannot discuss now about Python, all those things. That also you have to concentrate. That is a different thing. In communications, you have to concentrate these things. Okay. Clear, Nana? Sorry. Sorry. And second, they will ask you different things. That part I'm going to discuss now. So sampling is very important. In that sampling, what is Nyquist rate? Okay. This is very important. And aliasing effect. How to overcome aliasing effect. Okay. These things are very important. The great Nyquist proposed Fs equal to 2FM is minimum number of sampling frequency, minimum sampling frequency. Generally, we follow fs greater than 2fm, where fm is the highest frequency of message signal. If it is a speech signal, 300 Hz to 3.4 kHz. This is the highest frequency. 2 times highest means 6.8 kHz, means 6,800 samples within 1 second. But in general, we'll take 8 kHz, 8 kilo samples, 8,000 samples. Is it clear? Okay. So try to follow sampling, because that is one of the first step in analog to digital conversion. You know very well, PCM, pulse code modulation. So this is input signal. First you have to do the sampling, after that quantization, and after that encoding. And one more thing, Nana, one more thing. All of you should concentrate. In every interview, they will ask you about, explain about communication system block diagram. Compulsory question. Okay, communication system block diagram. Nana, I question paper leak chestna code based on interviews, based on my knowledge, I am telling. So try to concentrate. Communication system block diagram. If you represent transmitter, sir, and channel, sir, receiver, sir, that is not enough, Nana. Okay, they want more than that. What is that? Okay, information, transducer, now transmitter, channel, okay, and receiver, and destination. This is also not enough. You have to include source coding, channel coding. If you can, if you are explaining like this, means that is good. You started with this, that is not good. This is okay, but what is excellent, I will tell you. Okay, very good, I will tell you. This is very good. Source coding. Try to include source coding. Try to include channel coding, and explain that what is the importance of source coding and what is the importance of channel coding. That is information theory and coding. Okay, how we can demodulate the signal, that is excellent. And shall I tell you, this is very good. Shall I tell you excellent point? If we can include Ofdm also in our block diagram as a BTech student, is it excellent or not? So how we can include Ofdm, I will tell you. Is it clear, Nana? Try to explain block diagram means you have to draw 10 to 15 blocks. Okay, within 1 second, 2 seconds. Try to explain everything. Yes, that is enough. Yes or no? It means you know each and everything very clearly. Okay, so that is also very important. Okay, I can say. So you know the difference between sampling, quantization, and encoding. So try to understand what is sampling. I cannot explain now. Quantization and encoding. What is the purpose of PCM? To convert analog signal into digital signal. How many bits we are transmitting? What is bandwidth? Okay, and what is the data rate? That is also very, very, very important. Okay, clear. And next one is PCM. PCM is already over. What is DPCM? Okay, DPCM means instead of transmitting each and every, we will transmit each and every sample only. In DPCM, instead of transmitting directly sample value, it will predict the sample value. If you remember, these are all samples. For example, this is the signal. These are all samples. Take voice signal. Instead of transmitting each and every signal, it will predict the sample value. The prediction may be like this. The predicted sample. Sorry, is it possible to predict the sample value? Because prediction means before we are doing. Yes, it is possible. Okay, in communication, you can design some predictor based on previous samples, because signal may not change drastically. Amplitude value, signal will not change like this, Nana. It is not possible. Voice signal, it is changing like this only. For sample to sample, how much? 8,000 samples we are transmitting. 1 by 8,000 means 125 microseconds. Within 125 microseconds, signal will not change that much. In case of speech or some other signals, some cases we may not apply. Some cases we can predict. Exactly, we can predict, because what we are transmitting, we don't know. There may be some difference. Take that difference. Actual sample black line, red line is difference. If you consider that difference is very small. Now consider this as a sampled. Now apply quantization to this one. You will get what is the advantage. You can improve the signal to noise ratio, or you can decrease the bandwidth. How it is, I cannot explain, Anna. Time limitation. Study first. If you have any doubts, you can call me. I can say these 5 days you can call me. Okay, not a problem. I will guide you. Okay, my point of view. So this is the thing. Okay, Nana, clear? This is about DPCM. Now what is delta? Delta modulation. So DPCM means take the sample value and assign, do the quantization, and after that encoding. And what is DPCM? Take the difference and do the quantization and encode it. And what is delta modulation? So in encoding, in PCM and DPCM, what we will do? We may assign each sample 8 bits in PCM. In DPCM, we will take the difference, need not to assign same number of bits if you want to reduce the bandwidth. You can apply maybe 3 bits for each sample, okay, or 2 bits or 4 bits, like that. You can reduce the number of bits, okay, each sample. What is delta modulation? Each sample we will assign only 1 bit. So this is other name is 1 bit DPCM. Delta modulation other name is 1 bit DPCM. Is it okay? Clear, Nana? So that is some other advantages are there. Okay. Slope overload distortion, granular noise, those concepts also you have to know. What is slope overload distortion? Okay, and granular noise. Okay, all these things you have to know. This is about some first part in digital communications. And what is the second part? Linear wave shaping. Then. Linear wave shaping. Okay, what is the advantage of linear wave shaping? If you take the PCM, if you give some signal to the PCM, it will convert into digital data, some digital data. If you want to transmit this data, is it possible to directly transmit this digital data? No, you have to convert into a signal. How to convert into this signal? By using linear wave shaping. It may be unipolar or polar or bipolar. I think you are getting my point. I think you are able to recollect each and everything. I think, okay. So unipolar, polar, bipolar, Manchester, differential Manchester, all these things are there. So try to understand that also. Is it clear? And next one is ISI. Very important one. Because same thing you use in Yftm, orthogonal frequency division multiplexing. In digital communication, we discuss like a concept. What is the Nyquist criteria? What is the solution Nyquist proposed for this reduce ISI? We know that one. Okay, clear? ISI. But same thing we apply in Yftm also. But we will not discuss anything that point of view in digital communications because you don't know about Yftm. But same thing will apply. What is the problem? I will tell you. For example, I want to transmit 101101. This is 101101. Very important, man. I can say ISI. This mostly we'll discuss in Yftm. Okay, because of that, very important. At least if you can talk about this point also, good, yes or no. Okay, if I radiate the signal, signal shape will change. If I transmit this signal shape will change. Okay, why? What is the bandwidth of the signal? If I take pulse, what is the pulse bandwidth? You will get sync, Fourier transform of pulse. Or what is this, Nana? Rectangular pulse, yes. Rectangular pulse. If you consider rectangular pulse, you will get a sync function. What it means, a sync function? This is Fourier transform, this is time domain, this is frequency domain. See here, this will go up to infinity. What is the bandwidth of the signal? Is infinity or not? The bandwidth of the signal is infinity. Is it clear? But channel bandwidth, is it finite or not? Channel bandwidth is finite. It doesn't have infinite bandwidth. We cannot transmit all the frequencies. We can transmit FM 88 to 108 MHz only. Why 88 to 108 MHz? Yes, we can transmit in that range of frequencies very well without any attenuation, without a less bit error rate. Lot of things are there. Practically, they have done lot of work. Finally, they proposed this bandwidth. Is it okay? Not that much, just like that. Is it okay? Not just like that. So you are transmitting infinite bandwidth signal through a finite bandwidth channel. So automatically signal shape will change. This is the signal in time domain and transmitting. Signal shape may be like this, it will change. Second signal may be like this, third signal may be like this, maybe fourth signal. Is it clear? This signal is entering into the next symbol. This is called as a symbol. First symbol, second symbol, third symbol is entering into the fourth symbol. Fourth symbol is entering into the fifth symbol and also second symbol, like that. Spreading of the signal. Okay, clear? That is nothing but interference. Okay, now at the receiver side, I have to take the decision, yes or no, whether it may be 1 or 0. Can I take the decision? Is it possible? No, because where I can take the decision already spread. Okay, this is like a noise, I can say. Okay, no one will tell you like this is noise like that. Just ISI, intersymbol interference. Okay, clear? Anyway, what Nyquist proposed for this, because it is very useful in Yftm also because of that. What Nyquist proposed. What is the solution for this? What Nyquist proposed is, instead of transmitting rectangular pulse, if in time domain, can I transmit sync pulse? Okay, can I transmit sync pulse? Okay, in time domain. See here, you have to understand few things. This is time domain. If you find Fourier transform, frequency domain, it will occupy infinite bandwidth. So what is the idea? In time domain, if I transmit this one, okay, sync function. What is the Fourier transform of this one? Rectangular pulse. Am I correct? Is it finite bandwidth or not? Yes, it has. It will occupy only some particular. That is the excellent idea by Nyquist. Okay. So if I transmit sync, yes, now I will tell you 1 0 1 1. I am transmitting. 1 means transmit some sync function. Okay, this is the bit duration, I can say. This is the bit duration. Okay, clear? And at 0, no signal means I am not transmitting. Again 1. Yes, I have to transmit 1 like this. Yes, sir. Again 1. Again 1 means here. Again 1. Sorry, here you will get. Anyway, leave about this one. Okay, 1. Now this is also like a. I cannot take a decision, but yes, we can take a decision because of that. If you observe signal, it may have a lot of amplitude variation signals here, sync functions here, but at every time instant, if you observe, every signal will touch 0 except this signal. This signal is having, okay, magnitude, high magnitude at this point. Am I correct, Nana? But remaining time instants, if you observe, maybe it has infinite values. If you add all these infinite values, if it is above threshold value or below threshold value, if it is above, generally with threshold value, we take decision as 1. If it is below, but at this point, it has only one value. Observe this one. That is the great idea of Nyquist. Is it clear? So now we can take. You can transmit this signal. Bandwidth is also finite. Yes, it is possible. That is Nyquist's first criteria. This is practical implementation is having some problem. Nyquist proposal second criteria, and also Yo binary pulse, all these things, try to refer those concepts. Is it clear, Nana? This is about this part. And also, then I will complete within 3 minutes. Okay. Just we have to discuss MIMO and Yftm, Nana. I'm having some importance in that. Okay. How many are there in class? 13 members. Okay, good. Why I'm explaining like this means I think all are interested. Okay, you are spending time now means you are interested, and because of that I'm trying to explain each and everything. Okay, it will utilize it, Nana. Don't think this is not useful. Surely it will be useful. Okay, I will complete within 3 to 4 minutes. ASK, FSK, PSK. What is this? Digital modulation techniques. In that, which is important concept means how to transmit and demodulate ASK, FSK, PSK signal, all these things. Constellation diagram is very important, Nana. Try to understand constellation diagram. Okay, try to understand not only PSK concept, try to know about QPSK, because most of the times they use QPSK. This is PSK is nothing but BPSK, Nana, binary, quadrature, and 8 PSK, 16 PSK. All these things are very important. Try to know about, at least know. And try to know about QAM also. Okay, and QAM means quadrature amplitude modulation. Okay, try to know about this also. And bit error rate. This is very important. What is bit error rate? Okay, for example, if you remember ASK signal, how we transmit ASK signal, we will take some digital data 1011. If you multiply with root over 2 by TB, I followed this notation in our classes. You may know or not, I don't know, but I followed this one. Not only myself, Nana, most of the people, IIT people also follows this. This is from Simon Hicken textbook. Okay. Anyway, 1011. This is root over 2 by TB into cos 2 pi FCT. Okay. If I multiply this signal, this is 1 means root over EB amplitude, 0 means 0 only. 1 means root over EB. Here you will get root over 2 EB by TB cos 2 pi FCT. Is it okay? If it is 1, you will get this signal. 0 means you will not get any signal, because 0 multiplied by something means 0. In demodulation side, we will use coherent detection. Coherent detection is nothing but again multiplication with the same signal. In that case, if you finally demodulate and finally you will get root over EB and 0. If root over EB, we consider that as a logic 1. If it is 0, we consider that as a 0. I think you are getting my point. Simply I will explain. At the receiver side, I am getting plus 5 volts and 0 volts. Nana. Generally, what we will do, we will consider threshold voltage. Okay. Okay. What is threshold? Generally, we consider threshold voltage as a middle point. This concept is very, very important. 2.5 volts. If the receiver signal is greater than 2.5 volts, I consider as a 5 volts. If receiver signal is less than 0 volts, I consider as a Y threshold. Along with the signal, there may be a considerable noise amount also. So already signal is there. Noise will be added to the signal. If it is above threshold value, if above 0 means we cannot consider like that. If noise is having some part, if you consider above 0 means it has a noise. Instead of signal logic 1, you will get the signal like this at the receiver side. Because of that, we will take the threshold. Threshold is always middle value of the received signal. What is the received signal in our case? Root over EB and 0. What is the threshold value? Root over EB by 2 in case of ASK. Is it okay, Nana? Clear? So concentrate. Now, what is bit error rate? What is bit error rate? I am transmitting 101101 something. For example, 100 bits I transmitted. Within 100 bits, if I received like this 111101, where is the error? Second bit error. For example, if I transmitted like 100 bits, if 10 bits are error, what is the bit error rate? 10 by 100. Is it equal? So 0.1 is the bit error rate. That is the calculation. How many bits are error if I transmit? That is nothing but bit error rate. Okay, clear? But in general, how many bits we are transmitting? Large number of bits we are transmitting. Because of that, okay, this is random generation of signals. Because of that, we will find probability of error. What is the probability in term? Not like this. 10 bits error, 20 bits error. Not like this. In general, finally, if we calculate value, we will get probability of error also. Okay, clear? Okay, sorry. ఒక 2 minutes ఏమైనా బ్రేక్ కావాలన్నా కంటిన్యూ చేశానా? Okay, I will continue. Okay, not required, I think. Try to concentrate. What is bit error rate? Okay, root EB means it has some value. Yes or no? EB is the energy of the signal. Root EB means it has some value. Root EB by 2 is the threshold value. Okay, for example, this is the noise. Okay, just I will give you the hint. Based on that, you can analyze. This is the noise part. This is, for example, root over EB by 2 value. And this is root over EB by 2. If I, for example, I transmitted 1. I received root EB. Okay, I received root EB. Okay, if it is greater than root EB by 2, I consider this as a logic 1. Reconstruction. I transmitted. Okay, some signal 1 means in the receiver side I will get root EB, means some positive value. If it is above root over EB by 2, I consider as a 1. It will be detected as if it will be detected as a 0, that is nothing but probability of error. Error means 1 detected as 0, 0 detected as 1. What is probability of error? Means already actually we have to get root EB, but this will be detected as 0. When it will be detected as 0? If noise is added to this one, for example, shall I consider this as 2, Nana, for understanding purpose? Root EB I am considering as a 2, may not be practically, just for understanding purpose. Whatever root EB by 2, 2 by 2. So if it is 1, if it is greater than 1, without noise, it is 2. If it is above 1, yes, I can detect. When it will be detected as 0, if it is less than 1, means if noise is added, if noise voltage is greater than how much? Minus root over EB by 2. Yes or no? Am I correct? Means consider if noise voltage is greater than less than yes, minus 1. For example, add minus 2 nano. Okay, this is 1. Add less than minus 1. Less than minus 1, yes. Am I correct? Less than minus 1, yes. Minus 2, minus 3, minus 4. From minus 1 onwards, if you add minus 1, minus 2, minus 3, minus 4, this crosses 0 value. Am I correct? For example, add minus 1.1. Already 2 value is there. I'm adding minus 1.1. How much you will get? This region you will get. If this voltage, actually 2 volts, is entered into this region, this will be detected as a 0. Am I correct? So if it is in this region, 1 detector. What is transmitted bit? 1. How I am receiving? 0. Probability error of 0, 1. Okay. When it will be? If the signal is in this region. Similarly, probability error of 1 by 0. Transmitted 0. Received as a 1. When it will be? If the signal is in this region. Am I correct? So if you can integrate, what is the probability of the signal in this region? If you integrate total signal, you will get 1. Am I correct? But if integrate particular portion, means integral root over EB by 2 to infinity. Okay, Gaussian function 1 over root over 2 pi sigma square, you know very well. If you integrate this one, you will get the probability of error. Generally, you represent in Q function. What is the Q function? You know, Q of U is 1 by root over 2 pi integral x equal to u to infinity e power minus x square by 2. Okay, dx. See here, Q of U. This is U. This is U. For example, Q of 2 means function should be 1 by root over 2 pi integral x equal to 2 to infinity e power minus x square by 2 dx. Is it okay? This you can write Q of. Similarly, by using Q function or complementary error function, this is also you have to know root over 2 by 2 pi integral x equal to u to infinity e power minus x square dx. Is it clear? Based on Q function and complementary error function, we can analyze bit error rate. Okay, Nana? Clear? Now, okay, I'm not going to discuss about information theory and coding. Try to know about source coding, Huffman coding, Shannon-Fano coding, what is information, what is entropy, okay, and linear block codes, cyclic codes, convolution code. In one of the interview, they asked about explain about Viterbi decoding. Viterbi decoding. You can see. First, do that. Watch that video. Okay, immediately after this class, if you are interested to work in Qualcomm. Okay, not only Qualcomm, in communication side, if you want to work in any company, I think 4 to 5 companies, good, excellent companies are there. If you want to work, okay, you can see all these things. Viterbi decoding. Just 1 minute. So they may ask what is the convolution code. Okay, what is Viterbi decoding? How we can decode? Why it is the best method comparatively remaining? What is linear block code? What is the advantage of channel coding? These are all comes under channel coding. All these things we have to refer. Is it clear? Don't think all these things shall I study. Okay, yes, you have to. At least you have to refer these 4 to 5 days daily. You will get surely. Okay, they will impress me. You know already basics need not require, but this part. Okay, now this half an hour concentrating OFDM. That is enough, I think. OFDM. Signals and systems, and one more point I want to add, 1 minute. In digital signal processing, you have to know about the difference between Fourier series. Fourier series we will apply for okay, periodic. Fourier transform we can apply for non-periodic, and Laplace transform and Z transform. Just the equations at least you have to see. Laplace transform and Z transform. Laplace transform for continuous, Z transform for discrete. What is the difference between Laplace and Z transform? What is the advantage of Z transform? You know digital signal processing subject also. The advantage of Z transform also, you know, you can and IIR and FIR filters now. That is very important. You have to know about IIR and FIR filters. Okay. What is the difference between infinite impulse response and finite impulse response? Okay, filters you have to know, and also multi-rate, decimation and interpolation. Decimation, if you know, anyone let me know. Do you know this concept, Nana? Decimation and interpolation. Have you heard about this one?
Yes, sir.
Very good, Nana. So you should know. Signal processing, surely they will ask about this one. This is nothing but multi-rate DSP. Am I correct, Nana? Multi-rate DSP. These are all very 90% they will ask these 4 only. Remaining, don't concentrate more on time shifting, frequency shifting. Anyone can answer. Yes or no? You should refer. But if you are good in that, what is IIR? What is a FIR filter design? What is decimation and interpolation? If you answer this question, okay, that is good. In one interview, one person told about this question. Not only one person, most of the people. They are asked common questions only every time. They are having lot of work in Qualcomm, yes or no? They have to design all these things. They constantly last 5 minutes we will discuss all these things. So leave about it. Okay. Decimation and interpolation, IR and FIR filter. Try to concentrate again and again and again. I am repeating. Okay. So next, Ofdm. I think you don't know anything about Ofdm. No, anyone? Lab, okay. Leave about lab. Final year you have lab. Except lab, do you have any idea about this orthogonal frequency division multiplexing? Okay, I will try to explain what is the basic idea behind this. Multipath feeding, you have to know this concept now. Multipath feeding. Just give me 1 minute. I have some notes. I refer. Try to explain more clearly. To recollect some of the formulas, all those things only. Okay, have some short notes. Anyway, I prepared short notes from class and some of the what is that standard textbooks. I will show you some of the standard textbooks last 5 to 10 minutes. If you want, I will share you, not a problem. Okay. Okay, multipath propagation channel. You have to know about multipath. Very important concept. Now, if you can explain this concept, this 1 hour discussion, I think 1 hour 15 minutes discussion, okay, anyone can do. But if you are good in this, surely they will give you job. Nana. I can say, because this you have to know. They want this only. LTE network, they want all these basics. Okay, that is good only. You have to implement LTE protocols. I will show you what are the LTE protocols. What is stack? LTE stack. They ask you like this. Explain about LTE stack protocol. If you think like that, you didn't heard like this, don't keep our expressions like that. Okay, I know at least some things you can explain, not everything. No one can explain everything. Okay, no one is expert in all the concepts. Okay, we know something, that is good. Okay, to get a good job. Anyway, Ofdm, orthogonal. Before going to start Ofdm, I will explain about multipath propagation. I think you know this subject in wireless communications somewhere, but try to understand. Multipath propagation, what you have to study. Give him a 1 minute time. Okay, someone came, just give me 1 minute. Okay, so concentrate. Am I audible? Anyone please respond. My voice was sorry. Am I audible? Anyone?
Yes, sir.
Okay. So you have to know about multipath propagation. Okay, what is multipath propagation? For example, I transmitted signal, some antenna, some base station. For example, you know base station, Anna? You know this word base station. In 1G or 2G or 3G, they started with base station. After that, they changed the name. In 3G, call it as a node B. Base station only, different name. In 3G, they called as a node B. In 4G, now we are calling this as a E node B, evolved node B, evolved. Means they changed some protocols or something. They developed because of that reason, evolution. Evolved node B, base station. If you use this term, that is good. If I transmit signal to the evolved node B, is it good or not? Yes, that means you know something. Okay. So now base station is nothing but E node B. Same. Okay. Anyway, if I transmit this signal through E node B, means base station, the signal may go in different directions. Yes or no? This is called as a direct line of sight. This is called as LOS, line of sight. And also signal may reflect from different trees or maybe different buildings. Am I correct? Signal scatter. This is nothing but scattering. Scatter from same signal will reach the destination point, means receive. Okay, our mobile or maybe something. Okay, base station to some particular point in different directions. This is nothing but non-line of sight. which is shortest distance, line of sight only always. Okay. So different with the delay also signal will be received. These will be added, yes or no? Signal will be added at the receiver side. I'm talking with you. It will go directly, and also it will come from different directions. These are all practical advanced communications. You know, in analog and digital communications, we will not discuss all these things. This is nothing but multipath propagation. Is there any effect multipath propagation? Yes. So we'll start discussion about Yftm. Not only some particular faculty. Nana. If you refer any textbook, they will start discussion like this only, multipath propagation. So it has some effect. All these equations I cannot tell you. What you have to concentrate, I can explain now within my particular time. Okay. So try to concentrate on, okay, what is the effect of this channel? Is there any effect in bit error rate? What is the bit error rate? All these things you have to consider. Okay, clear? This is one point. Okay, for example, signal is reflected from different points. First signal is received. Okay, how we represent is del of t impulse we are transmitting, or some symbol s of t we are transmitting. You are getting my point. Because of this delay, t minus tau I. Am I correct, Nana? Impulse delay, and also some attenuation. Signal is transmitted in this direction, some attenuation, maybe long distance, maybe more attenuation. Is it okay? So transmitted impulse is, okay, del of t. Received impulse is del of t minus tau I. Is it okay? What is tau I? Tau naught. This is tau naught. Okay, this is tau 1. From other signal, some, not only one tree, different trees also it will be reflected. Lot of signals will be added. Okay, we have to know the concept of delay spread. Okay, you should know the concept of delay spread. What is delay spread? Delay spread is nothing but first signal is received is tau naught with the delay. Tau naught means del of t minus tau naught. Last signal received at this point is del of t minus tau I. Is it okay, Nana? So the difference between these two, time difference, is nothing but a delay spread. Is it okay, Nana? First signal is received at particular time interval. Second signal is received at some other particular time interval. The difference between these two times is nothing but delay spread. Practically, what is the delay spread? They may ask you. The practical delay spread is 2 microseconds. Is it okay, Nana? Clear? So within 2 microseconds only, every signal will be received at the receiver side. Not that much problem. After 10 hours, 1 hour, not like that. If I transmit a signal, at the receiver side I may receive directly or different directions. So this is the delay spread. Is it okay and clear? Remember this point. Now I'll start with the Yftm, orthogonal frequency division multiplexer. Okay. For example, you want to transmit some signal, some symbol by using 10 megahertz bandwidth. What is the bandwidth? We have to know what is 1G. I don't have time, Nana. Otherwise, I will explain all these things. How communication is evaluated. Okay, from 1G to 4G. Sir explained this. Sir started with this only. If you refer that book, Sir videos, you can get everything. 1G, 2G, 3G, and 4G. Not only that, different textbooks are there. I referred. If you want, I will share you. Okay, like this. Okay, 5G implementation stage. Within few 1 or 2 years, you will get here. Okay, already in testing stage 5G. Okay, already protocols, everything implemented. They are in testing stage now. Okay. Anyway, so bandwidth is very high. Bandwidth requirement in 4G is very high because we are transmitting a lot of things. Yes or no? They started with 10 kilobits per second. See, 10 kilobits per second, 10 kbps data. Yes or no? Now 200 Mbps 4G, 200 megabits per second data. They are expecting in 5G in gigabits now. 1 to 10 gigabits per second. Okay, they are expecting this much data rate, this much bandwidth is required. Okay, for example, Yftm, we are using Yftm now. Where we are using Yftm, you have to know about uplink and downlink. You know this terminology, uplink and downlink. What is uplink? For example, I have a mobile. I'm communicating with base station. Okay, this is base station. I'm communicating. Generally, we represent base station like this. Anyway, whatever it may be, this is base station. I'm communicating with the base station. I'm transmitting signal to some other particular person. So I have, through base station only I have to transmit. Okay. So this, if it is the base station, I'm communicating with the base station. Is it uplink or downlink? Okay, this is nothing but uplink. Signal from our mobile device to base station is nothing but to the base station is uplink. If base station is transmitting signal to the mobile, this is nothing but downlink. Is it okay? Remember this fine. Okay, so uplink and downlink, in which we use Yftm, they may ask you. In downlink, we are using Yftm. Base station is transmitting to the mobile users, different mobile users, not only mobile users, different devices. Okay, user equipment, we can call it as a UE, user equipment. This is the terminology. You have to know about this terminology. Our mobile, that is nothing but user equipment. Okay, users, we are user equipment. That is nothing but mobile or something, or your what is that, tablet or some other thing, your computer, maybe you are communicating with. Okay, these are all user equipments. Okay, so in downlink, in 4G real-time applications, I'm telling. Okay, in 4G we are using Yftm. In uplink, what we are transmitting, that is not Yftm, that is SCFDMA. You have to know about this also. What is SC? Single carrier frequency division multiplexing, multiple access. You know FDMA, yes or no? What is SCFDMA? Are you able to understand or not? Yes, if you know basic concepts, orthogonal. FDM, you know, frequency division multiplexing. What is orthogonal? You have to know. Is it clear? So some part I will try to explain, because if you know these basics, you can start very happily. You can refer any textbook without any doubt. Okay. So concentrate here, 2 minutes. So here I'm using, for example, what you know already, from that I will start. After sampling, I told you already, voice signal frequency range 300 Hz to 3.4 kHz. What is highest frequency? Please concentrate now. In my total lecture, this part is very important. Okay, 300 Hz to 3.4 kHz. This is the highest frequency. If I use the Nyquist state 2 times 3.4 kHz, what is this? 6.8 kHz. This is 8,000 samples per second. Okay, clear enough? So 8,000 samples per second. Each sample with 8 bits. Am I correct? Because of speech signal. It depends on number of quantized levels. 64 kilobits per second. This is the bandwidth we are using to transmit my signal. Number of bits is nothing but bandwidth in digital communications. Remember this point. In analog communication, what is bandwidth? Highest frequency minus lowest frequency. In digital communication, how many bits we are transmitting is nothing but bandwidth. So 64 kilobits per second is the bandwidth of my particular signal. Okay. What is the bit duration? How many bits we are using? For example, 101101. This is the first bit. This is time axis. First bit, second bit, third bit, fourth bit. How many bits? 64 kilobits. What is the each and every bit duration? Within 1 second, if I am transmitting 64K, I cannot represent here. Imagine this is 64 kilobits within 1 second. This duration. Am I correct? What is the each bit duration? Means 1 by 64K. Yes or no? This is 125 microseconds if you calculate. Okay, that is sample to sample. This is you calculate now 1 by 64K, whatever, very small value will get. Is it clear? Very small value. Similarly, if I use, nowadays data rate is very high, maybe I'm transmitting video or some other thing, 10 Mbps data we are using, 10 mega. So 10 mega bits per second. Within 1 second, 10 mega. What is the bit duration? Each and every bit duration 1 by 10 mega. Is it okay? This is in micro. Am I correct? 1 by 10 means 0.1 microseconds. Each and every bit. So I have to transmit a bit within 0.1 microsecond means 0.0000 and so on. Within this duration I have to transmit it. Yes or no? Now if I transmit this one, okay. So first concentrate now. 1 0 1 1. Leave about this one. 1 1 0 1 1 1 1. Think like that. I transmitted this signal. This is the bit duration. Sorry. What is the idea? I'm telling you now. What is the idea behind Yftm? This is the bit duration. Okay, clear? So you know already a signal. I transmitted this signal. I told you already multipath. Okay, feeding and multipath propagation. Okay. So what is the disadvantage of multipath propagation? If I transmit different signals, if I transmit a signal, it is received in different directions. All these added. Because of all these added, signal may be attenuated or amplified also. Is it okay? Because of deep feeding, I think you know the concept of deep feeding. What is deep feeding? Deep feeding is nothing but we may lost the signal at the receiver side, power attenuation is very high now. We have to maintain signal to noise ratio at the receiver side. Always we have to maintain signal to noise ratio. If signal power is very low because of this multipath propagation, we cannot reconstruct the signal. That is nothing but because of deep fading, because attenuation levels are very high. What is the disadvantage of multipath propagation? They may ask you. You have to give the answer. We may receive very less power at the receiver side. There is a possibility because of deep fading. Okay, fading there may be advantage. If you add all these signals, sometimes signal may be amplified, but sometimes signal may be attenuated. If there is any deep fading, means sometimes effect is very high, noise effect is very high. In that case, you may not receive. That is the disadvantage of multipath propagation. How you overcome? I will tell you later. Okay, just 20 minutes. Okay. This is the first signal, AI into del of t minus tau I. Am I correct now? Tau 0, tau 1, tau 2, tau 3 different signals. Second signal, time delay. I told you already what is the time delay. 2 microseconds. What is the bit duration? I told you 0.1 microseconds. What is the delay spread? 2 microseconds. After 2 microseconds means same signal may be received at this point. Yes or no? Just I'm assuming this as 2 microseconds. If I receive the signal after 2 microseconds like this, if I add all these things, is it good? No, we cannot reconstruct it. Interference is more. That is nothing but ISI, intersymbol interference. What is ISI? Because of multipath propagation. If you receive the signal more than, okay, what is this? Bit duration. If bit duration is very much less than, what is this? Delay spread. Our delay spread value is greater than bit duration, you will get a ISI value, intersymbol interference. I cannot reconstruct. If for example, if you receive the last signal, yes or no, what is the 2 microsecond? Difference between last received signal and first received signal. This is 2 microseconds. This is the last received signal. For example, if I receive the signal only with a small delay, can I? Yes, I can take. If I take the decision at this point, yes, I can take the decision. This is logic 1. Yes or no? We can take the decision at the receiver side. If it is more than this value, 0.1 microsecond, I cannot take the decision. That is nothing but ISI. If we give this answer, that is explained now. Okay. Clear? So to overcome ISI means reverse. Bit duration. If bit duration is greater than delay spread, there is no ISI. There is no ISI. How it is possible? This is possible by using Yftm. That is the advantage. Is it clear now? So to overcome intersymbol interference, they started Yftm, orthogonal frequency division multiplexing. What is the idea behind this? I told you already. Okay, this is 10 megahertz signal. Clear? This is 10 megahertz signal. Okay, if I use one carrier to transmit total bandwidth, this is the carrier. Okay, clear? So instead of that, I separated this into 1000 channels, for example, 1000 channels like this, small channels. Okay, 10 mega by 1000. Okay, clear? So small channels. So total bandwidth I separated into 1000 bandwidths. I think you are getting my point. Okay, 10 mega bandwidth I separated into 1000. So now we will get the very small bandwidth. 10 into 10 power 6, 10 power 7 by, what is this value now? 1000 means 10 cube, means 10 power 4. Okay, clear? Or very low, not a problem. Okay, so if I convert into small bandwidths, okay, now what is the bit duration? Calculate. 1 by 10 megahertz. What is this? 0.1 microsecond. Now 1 by, this is small value, then it will be high value. This value should be greater than 2 microseconds. Am I correct now? What is required? Required thing. Bit duration should be, previously it is 0.1 microsecond because I am using 10 megahertz, 1 by 10 megahertz, 0.1 microsecond. Now what I am doing now? I am separating total bandwidth into small bandwidths. Now what is the bit duration? Now I transmit separate carriers now. For this one carrier I will use, for this one carrier, for this one carrier, for this one carrier, for this one carrier, for this. more number of multi-carrier modulation we are doing. Instead of using one carrier, we will use multi-carrier modulation. Multi-carriers. What is the advantage? Bandwidth will be reduced. I separated into different bandwidths. Each symbol I am transmitting by using different carriers. Is it clear? What is the advantage? Bit duration should be greater than delay spread. Now there is no intersymbol interference. Because of that, what is the advantage? We can reconstruct the signal. Clear, Nana? Okay, just the idea I'm giving. Try to refer that book. Okay, or sir videos. Okay, and you may have some problem. What is the problem in Yftm? Okay, if I use different carriers, how many carriers I have to use? So many carriers. Okay, in transmitter side only. Is it possible to use so many carriers in the transmitter side? No. The number of oscillators I have to design, something big process now. Instead of that, what they will do is, I cannot use mathematically. What they will use, actually data input is serial. Yes or no? Serial symbols 101101. Is it serial transmission or not? Now I convert into parallel initially. What is Ofdm? Parallel. First bit 1 0 1 1. Symbols will come like this. What I will do is, I will apply, instead of using so many carriers, I will apply inverse fast Fourier transform. Why? Try to refer any one material. I cannot explain mathematically. It will take 3 to 4 hours time now. Okay, but idea I'm giving. I told you in communication block diagram, try to include this also. This is Ofdm process. Inverse fast Fourier transform. What is the advantage of inverse fast Fourier transform is, it will give the signals like this. Okay, first signal. Okay, first signal. It will convert, instead of using so many carriers, it will convert into that form. Okay, first signal, second signal. Have you seen this before? Yes, Nyquist proposed concept. Yes or no? Where they will take decision at the bit rate. Same concept only. So instead of using so many carriers, by using inverse fast Fourier transform, we convert each symbol into this form. Each and everything is orthogonal. Okay. Okay, clear? Why it is orthogonal also? Mathematically only we can prove. Okay, clear? So each and everything is orthogonal. If you use a separate spacing between carrier, okay, clear? So it will be converted into a different signals. Now I transmit all these signals. We will not use multi carriers now. Instead of that, we will use, nowadays VLSI design is excellent. We are getting chips to do fast Fourier transform. Okay, if I give bit into that chip, it will convert it into different like orthogonal frequency division multiplexes. Why frequency division multiplexes? Different carriers we were using, FDM, different carriers we will use. Each and everything is orthogonal. Why? By listening those videos, you will get each and everything is orthogonal. And what is the exact reverse process? Applied inverse fast Fourier transform means you have to apply fast Fourier transform. Now parallel to serial converter, finally you will get the data. Is it clear, Nana? That is the advantage of orthogonal frequency division multiplexing. What is the advantage main? To overcome the ISI by increasing the bit rate, by decreasing the bandwidth. Okay, clear? You have to tell this point. Okay. Any doubt, Nana? If you have any doubt, you can ask me. This is about Ofdm. Lot of things, bit error rate calculations, all these things are there. But this is the concept. You have to know minimum. If you have some time only, at least up to this point, you have to refer. Okay, clear? If you have more time, try to understand bit error rate. What is the difference between multipath propagation channel bit error rate, Ofdm bit error rate? Try to compare both the bit error rate with 100%. Ofdm bit error rate comparatively multipath propagation bit error rate. Ofdm bit error rate is very less. Probability of error. Am I correct? Why you use this technique? To avoid interference only. Surely you will get more bit error, less bit error. Probability of error is very less in this case. Okay. We have to compare like this only. By comparing bit error rate only, why we are doing all these things? Receiving signal in different places means nothing but noise. So how to overcome that? We have to take some parameter that is nothing but bit error rate. Is it okay? By comparing bit error rate only, you can compare best things. Okay, you can design also. Next, we have 15 minutes. I will stop within 10 to 15 minutes. I will explain MIMO. MIMO, multi input, multi output. Okay, what is MIMO? I told you already. I have a transmitter. By using antenna, I am transmitting. I have a receiver. By using antenna, This is single input, single output. Am I correct, Nana? Single input, single output. Means one antenna I am using. So signal will be transmitted like this, reflected from different objects. Okay, it will be reflected. We have to consider this signal, this signal, this signal. Not only that, what is the first received signal? This only, line of sight at some particular time interval, tau naught. Last signal maybe because of large some other trees also there in that path. Long distance also it may not receive, signal amplitude is maybe very less. Yes or no? If you consider what is the difference between first and last signal, 2 microseconds practically, not more than that. Don't think 1 hour, after 1 hour if I receive the signal, complete noise only. Okay. To overcome this, what we have done? We used multi-carrier. Practically multi-carrier implementation is a problem. For that we used inverse fast Fourier transform. At least we have to know that. Okay, clear? Anyway. So any deep fading channel is there. If there is any deep fading channel, deep fading link, yes or no? So signal will be attenuated. We cannot reconstruct it if it is a single input, single output. If you use some other technique, maybe you cannot reconstruct. So what they have done is in 3G also they implemented MIMO. Not only in 4G, 3G also they implemented Yftm and MIMO. Now with the different evolved communications they are using. This is transmitter. Okay, 10 more minutes. What is multi-input means? I transmit a signal by using different antennas. More number of multiple antennas, multi-input, multiple antennas at the transmitter side. What is multi-output? Multiple output at the receiver side. Is it clear now? Then what is the advantage? I transmitted signal. I received like this, like this, like this. This is also like this, like this, like this. This is also. If I transmit one signal, every antenna signal will be received by every antenna. Okay. Then what is the advantage? There may be one link is having deep fading. What is the disadvantage of deep fading? The disadvantage is we cannot reconstruct. The power is very less. Okay. But some other link will be good. Now we can reconstruct the signal from that link. Is it okay? That is the idea. That is the idea behind MIMO. Okay. If there is any, you have to answer like this. What is the advantage of MIMO? They may ask. You have to answer. Give the answer like this. There may be one channel deep feeding by transmitting signals by using multiple antennas, receiving by using multiple antennas. That is multi-input, multi-output. Okay. There may be one channel deep feeding. From remaining channels, we can reconstruct the signal. That is the great idea. Previously, they used only one antenna. Now they are using multiple antennas to transmit multiple signals. Okay, clear, Nana? So by using that, we can reconstruct the signal. That is nothing but MIMO. And this also you have to analyze and you have to calculate. You have to prove this is the best by using bit error rate. Okay, clear? Lot of things are there, Nana. 20 hours class. I told you already, 20 hours. If you refer standard textbooks like this, I will show you some of the textbooks. Okay. I downloaded some of the textbooks by referring some of the IEEE professor videos or something, internet or something. See? And one more thing is Lte Stack Protocol. I have that. I think it is visible. Lte Stack Protocol is nothing but. Now, do you know about OSI model? OSI, computer networks.
Yes, sir.
Yes, that is nothing but LTE architecture. Okay. They may ask you how signal will be connected to the base station. Directly, now you cannot tell directly. What you have to tell? Physical layer, network layer. I think you know. Okay, that information is there in this textbook. See here, physical layer. All these things not required. Everything is not required. I told you, no one knows all these things. Okay, MAC layer. Okay, some protocols are there. They specified clearly. You have seen, I think, SAR sent in that group also. They specified clearly that came from Qualcomm. They specified clearly what they specified. LTE protocol. So first give the importance to this one. How signal will be connected to the base station? How base station will send the signal? What is the importance of physical layer? Physical layer means totally we will discuss about signals. This Yftm, all these things. Maybe what is that? MAC. The purpose of MAC is different. That's a purpose of some other layer. Okay. All these things are different. All these things are here. Okay. So try to understand each and everything. Okay, what they discussed in chapter 3, see here protocols. Don't neglect this one. Don't think that is entirely different concept. LTE protocols may be different. 1G protocols different, 2G protocols different, 3G protocols different. The evolved node B, I told you already. Evolved node B, UE, user equipment, other E node Bs. Just refer this one. How much time I have to prepare, sir? Not required. If you have 1 hour time, 1 hour refer. MMA. One interview, one person told. They asked me about MMA. What is the purpose of MMA? This line you study, what is there? All these things not required. If you have time, yes, you prepare it. Okay. As a BTech student, they may not ask you each and everything. Yes, this see here. MMA connections to other architecture. This is nothing but architecture. How signal is connected. Architecture is nothing but what are the steps involved in that. Okay. I will send you some of the textbooks in that you can refer. As many as possible, you prepare about Yftm, MIMO, and Lte Stack Protocol and Lte architecture. Remember these 4. Okay. Remaining things everyone knows. Everyone may. What is 3GPP? And that's they specified. If you say what is 3GPP, third generation partnership project. I will tell you 1 minute about that. What is 3GPP means? Okay, some group of people in communications related, all over India, they specified some standards which you can implement practically. 3GPP means third generation partnership project. Okay, they started giving some rules and regulations. What is the bandwidth? What is the data rate for 4G? What we can achieve from that? What is practical reliability? All these things they specified. They changed every year. Next year, after a lot of advancements in different places, they have taken it. They considered all these things. They specified. We can implement it. I can say 3GPP standards are nothing but we can implement it. Open 3GPP standards in internet. You will get some information. At least you have to know what is 3GPP. I told you which we can implement practically. They specify what is data rate, what is bandwidth, what are the things we can achieve from this. Is it okay and clear? So that is also, and see here, physical layer, medium access control, radio link control, packet data coverage protocol. What is the function? This protocol is control the radio resources. At least you have to refer these things. You have to study. These things will not be covered in our lecture. You have to. Okay. Protocol stack. I told you already. Protocol stack. This is protocol stack in EPS only. Not EPS. Protocol stack for LTE is also there. I told you no one can explain each and everything. See here, UE to E node B. How connection will be established between, they ask you. In one interview, some person told how UE is connected to E node B. That is compulsory question he told. So you have to tell at least what is PDCP. If you are talking as a BTech students, PDCP means they understood you studied something. Always you are talking what is amplitude modulation, what is digital communication. No. Something more you have to do. What is S1U? What is S5U? What is the SGW? What is PGW? Don't think it will take hardly 4 to 5 hours now. You can understand each and everything very clearly. I can say 4 to 5 hours. Once refer this book, you can understand. If you want, I will send this book. Okay, clear? You can message me. I will send it to you in order. Evolved ETRAN. Okay. Not only this one. I have MIMO, Ofdm. Not just like that I downloaded. By referring some of the materials, I thought these are the best books. Okay, not just like that. What something is there in internet. I have not downloaded like that. Some information is there. Everything is there only. Try to use this book also. And also MIMO, Ofdm, wireless communication with MATLAB. And one more thing, once refer MATLAB also. They want C language in MATLAB now. And Python they specified, I think, in our okay. I think they specified C, and if you know MATLAB, that is great advantage to them because they are using MATLAB also. Anything else you want to discuss? Already time is over, I think.
Sir, can you share the YouTube links you mentioned?
Yes, sure. Okay, you send me one message. I will share it to you. Okay.
Okay.